Okay, so today we're going to cover section 3, and in this lesson we're going to be proving lines are parallel. So we are going to be seeing the converse of the one postulate for the corresponding angles and all the theorems for all the other angle pairs. And it'll be the converse of what we learned in section 2. So, for the corresponding angles converse postulate, states if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So before in lesson 2, they started out the statement by if the lines are parallel, then, or if the lines are parallel and cut by a transversal, then corresponding angles are congruent. So now this is the converse. So as soon as we can see that these are congruent angles because they're corresponding, we can prove that line J and K are parallel. So if you wanted to write this with like some shorthand, you could say, if line J and K are cut by a transversal and angle 2 is congruent to angle 6, then we could say J is parallel to K. So when you're describing these as reasons, you would either tell me it's the converse of the corresponding angles postulate, or you would state and you would write it out in a sentence and explain what the postulate says. So 2 and 6 in this picture are corresponding angles. And because they are congruent, you can prove that line J is parallel to line K. Anybody still need the slide? Next. Now we're going to see the two theorems for the alternate interior and the alternate exterior. And again, these are the converse of what you learned in lesson 2. So if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So basically if, and let me draw a figure here for you. Two lines cut by a transversal, and let's say it creates 1, 2, 3, 4, 5, 6, 7, 8. Then if we could see that 3 and 6 are congruent, or 4 and 5, then we could say if angle 3 is congruent to angle 6, then, and I could call this again J and K, then J is parallel to K. For the alternate exterior, we could say angle 1. So if angle 1 is congruent to angle 8, then line JK. J is parallel to K. So that would how you would prove those. Yes?
So I can prove like J and then the two lines were parallel, and then K and then we put the alternate interior angles converse, like if it's 5 and 6.
Yes.
4 and 5, sorry.
Right, 4 and 5 would be alternate interior. If it were 1 and 8 or 2 and 7, you would say by the alternate exterior angles converse. So these proofs, or I'm sorry, these theorems in the postulates we're seeing now, these are going to be ways that you can prove lines parallel. On the alternate interior, you could also say angle 4 congruent to 5. So if 4 congruent to 5, then again, J parallel to K by alternate interiors. And the other alternate exterior pair would be 2 congruent to 7. And J parallel to K. The next theorem is the consecutive interior angles converse. Remember, we also saw this as same side interior. Same side. So if you ever see consecutive interior, it also means same side interior. Angles converse. So again, if I were to draw two parallel lines, or they're not, we don't know if they're parallel yet, and add in 1, 2, 3, 4, 5, 6, 7, 8. Now notice in this one, they're not congruent, they're supplementary. So for here, if I said if angle 3 plus angle 5 equals 180, then I could say that, again, I could call it JK, then J is parallel to K. You could also say 4 and 6. Or angle 4 and angle 6. Those are the same side interior or consecutive interior. We're on the same side of the transversal, but inside the parallel lines. And this is the consecutive interior angles converse. The next one is called the transitive property of parallel lines. And what this one states, that if two lines are parallel to the same line, then they're parallel to each other. So basically what I'm going to have here are 3 lines. And I'll name them E, F, and G. So if I state that if E is parallel to F and F is parallel to G, then just like my transitive property, E is parallel to G. Notice how the two F's here are the same. So I'm applying the transitive property, and I can show that if you have two lines parallel to the same line, then they're all parallel to each other. All right, now, these are 5 ways that you could prove 2 lines are parallel. So when you're writing your proof, look for one of these situations. Either show a pair of corresponding angles that are congruent, show a pair of alternate interior angles congruent, show a pair of same side interior angles as supplements, in a plane, show that both lines are perpendicular to the third line, or show that both lines are parallel to the third. That was that last by the transitive property. So any of these 5 suggestions here are ways that you can prove 2 lines are parallel. These are going to be things to look for. So here's an example. Now, it wants us to come up with which segments here, is it AB, AC, AD, which 2 lines here or line segments are parallel, and how do you know that? Now, before when we were looking at these pictures, they all had matching numbers. Right now, looking at this, do we see any numbers that match? No. So we're going to have to do a little bit of addition here to try to figure out. So what if we looked at angle CAB here, and then EB, and there's not a point here, but this angle here. So angle B and angle A. So what if we add these numbers? 22 plus 38, what do you get? 60, good. So this whole angle is 60, and this angle over here is also 60. So think of these as the pair. Now, what you can do is to figure out where the transversal is. If you were to connect this, see how they both are on this same line? This is your transversal, and here are my parallel lines. And we know this because of the converse of the corresponding angles postulate. These are corresponding angles. So we could say that segment AC is parallel to BE because of the converse of the corresponding angles postulate. So it might help you to draw or trace around the angle so you can see where the transversal is. Some of the problems are going to get a little bit more complicated, and you're going to have multiple transversals in them, and it's going to be hard to pick out. So highlight the angle we're referencing. Yes?
Was the corresponding angles converse postulate?
Yes. Anybody still need it? Sometimes you're going to have to turn it because they're not going to be drawn like when it was taught to you.
I see it, so it's that way and that way and that way.
Yes. So sometimes you're going to be rotating your iPad, or if it's on a piece of paper, you're going to be turning it so you can see it a little clearly. All right. What value of x makes AB parallel to CD? Manuel? 50. We can see that these again are corresponding angles. So this needs to be 90. So what are we going to add to 40 to make it 90? It's going to be 50 degrees. Because again, they're corresponding angles. And if we can show that they're both perpendicular, and when they're both perpendicular to the same line, we know that 40 plus 50 is 90. Pretty good on the slide? Yes. And we're going to do some more X and Y's. All right. So for what value, and now we have two different pairs of parallel lines here. So we got two transversals and two sets of parallel lines. So we can see that J is parallel to K. So J and K are parallel. And then we also have that L and T are parallel. So we can look at this two different ways. We can turn our iPads and turn the picture so we can see things differently. So how can we find out the value of either X or Y?
Well, first you need to find the measure of the actual angle. So, you know that 60 and 2y are both what do they call it? The opposite side. Yeah, alternate interior angles.
Good. 60 and 2y are alternate interior angles. So what do we know about alternate interior angles? They're congruent. Good. So 60 is equal to 2y. And then I divide by 2. And I find out the value of y is 30. Good. So y equals 30. Now, what about x? What's its relationship, Isabella?
It's corresponding to 60.
Okay, corresponding to 60.
So it's an congruent.
Again, corresponding angles are congruent. So I will start out by dividing by 3. And my x is 20. So because they told me my lines were parallel, that's what allows me to set them equal to each other. As long as you realize that On 60 and x, it's a corresponding angles pair, and 60 and 2y, those are alternate interior pair.
So
Yes.
this one would answer would just be the corresponding angles postulate, not converse.
This, well, for the 60 and the 3x, yes, we're using the corresponding angles, and the other one would have been the alternate angles theorem.
Alternate angles here, but.
Yeah, but not the converse.
Okay.
Yes, because they already told us they were parallel. And here is an application problem. And it's saying, how can you tell whether the sides of the pattern are parallel in the photo of a diamondback snake? So we're going to go ahead and zoom in on this enlarged little circle here. And notice right now we have some lines here and here and this line. And then we also have these little angles marked. So what kind of angles are these? Anybody know? Good. Alternate interior angles. And because they have the same congruency marks, we know that they're congruent. So yes, we could prove that those sides of the pattern are parallel because of the alternate interior angles. The converse of it. So we could prove that they are parallel because we have a pair of congruent alternate interior angles. All right, so your homework tonight is 3-3 Practice B. Again, your test is Thursday. Your study guides are up there if you want to start looking at them. Again, you're going to need to memorize all of these new theorems and the converse and the postulates. We still have one more lesson tomorrow, and then Wednesday I'll take any questions for you in our attempts or in our process of reviewing for the test on Thursday. And again, it'll be the last grade of the first quarter, and then on Friday we start 3-5 and continue on for quarter 2.